October 15, 1943, 0630 hours. North Pacific, 240 miles southeast of the Aleutian Islands. When Lieutenant Commander Takashi Yamamoto's submarine I-47 surfaced alongside the burning wreckage of what should have been an American destroyer, what his crew discovered about American ship construction would shatter everything the Imperial Japanese Navy believed about naval warfare. The Americans weren't just building ships faster than Japan could sink them, they were building them in ways that defied every principle of naval architecture the Japanese had mastered over centuries. The periscope footage that Lieutenant Commander Yamamoto transmitted to naval headquarters that morning would fundamentally alter Japanese naval strategy for the remainder of the war. What appeared to be a standard convoy attack had revealed something far more disturbing than any tactical defeat at T-0545 hours. I-47 had fired a spread of 4 Type 95 torpedoes at what sonar identified as a Fletcher-class destroyer escort. 2 torpedoes struck amidships, explosions that should have broken the vessel's back and sent it to the bottom within minutes. Standard Japanese naval doctrine, based on decades of combat experience and rigorous engineering calculations, predicted immediate catastrophic failure. Instead, Yamamoto watched through his periscope as the American ship absorbed damage that would have obliterated any vessel in the Imperial Navy's fleet. The destroyer remained not only afloat but combat effective, its guns still firing, its engines still turning. Steam poured from ruptured compartments. Yet the hull maintained structural integrity that Japanese naval architects had deemed physically impossible. The ship should be sinking, reported Chief Petty Officer Hiroshi Tanaka, I-47's most experienced torpedo specialist. 2 direct hits amidships. Any Japanese destroyer would be on the bottom. But this American vessel continued fighting, maneuvering, and calling for assistance as if the torpedo strikes were minor inconveniences rather than mortal wounds. What followed challenged everything the Japanese understood about naval construction. As I-47 maneuvered for a second attack, Yamamoto observed the damaged destroyer maintaining course and speed. Emergency teams moved across the deck with systematic efficiency, but there was no panic, no preparations for abandoning ship. The vessel's behavior suggested structural capabilities that contradicted fundamental principles of shipbuilding. The second torpedo spread, fired at 0612 hours, scored another direct hit. This third torpedo should have completed what the first 2 had begun. Instead, the American destroyer absorbed this additional damage and continued operating. Through his periscope, Yamamoto could see that the ship's superstructure remained intact. Its radar continued rotating, and its radio masts still transmitted distress signals. Naval intelligence files captured after the war revealed that this engagement prompted the first systematic Japanese investigation into American shipbuilding techniques. The incident report filed by Yamamoto reached Admiral Somu Toyota within 72 hours. Marked with the unprecedented classification, immediate strategic assessment required, enemy naval construction capabilities. The implications extended far beyond a single torpedo attack. If American ships could absorb damage that would destroy Japanese vessels, then every calculation about naval warfare needed revision. The mathematics of attrition, which formed the foundation of Japanese naval strategy, assumed equivalent vulnerability between opposing fleets. Yamamoto's final transmission before I-47 submerged contained a statement that would haunt Japanese naval planning. Enemy vessel construction appears to employ unknown structural techniques. Conventional torpedo attack effectiveness severely compromised. Request immediate technical analysis of American shipbuilding methods. The destroyer that should have sunk that morning limped back to port, providing American engineers with valuable damage assessment data. For the Japanese, however, the incident marked the beginning of a disturbing revelation about American industrial capabilities that would reshape their understanding of the war itself. The revelation that emerged from I-47's encounter was just the beginning of a systematic intelligence nightmare for the Imperial Japanese Navy. Within weeks of Yamamoto's report, similar incidents began accumulating across the Pacific theater. Japanese submarines, destroyers, and aircraft reported American vessels surviving damage that should have been instantly fatal. The pattern became undeniable by November 1943. At the Battle of Cape St. George, Japanese destroyers scored multiple hits on American light cruisers that continued fighting effectively. During the Marshall Islands campaign, Japanese pilots reported bombing runs that should have sunk American transports, yet the same vessels appeared in subsequent engagements. Each incident reinforced a disturbing conclusion. American ships possessed structural capabilities that Japanese naval theory considered impossible. Captain Jisaburo Ozawa, commanding the Combined Fleet's Technical Assessment Division, initiated what became known as Operation Tetsukabe, Iron Wall, in December 1943. This classified program aimed to understand American shipbuilding techniques through captured materials, prisoner interrogations, and systematic analysis of engagement data. What Ozawa's team discovered challenged 3 centuries of naval architecture principles. Traditional Japanese shipbuilding, perfected over generations, emphasized precise craftsmanship and optimal materials utilization. Each vessel represented months of careful construction by master shipwrights who understood every joint, every stress point, every structural element. Japanese destroyers and cruisers were engineering masterpieces, built to exacting specifications that maximize performance while minimizing weight and materials consumption. American construction appeared to follow completely different principles. Intelligence reports suggested that American shipyards were producing vessels in time frames that Japanese experts calculated as physically impossible. The Bethlehem Steel Corporation's Four River Shipyard reportedly launched destroyers every 14 days. Japanese construction of equivalent vessels required 6 to 8 months minimum. "They are building ships like we build aircraft," reported Commander Yoshio Suzuki, Ozawa's lead technical analyst, after reviewing captured American construction photographs. Mass production techniques, standardized components, assembly line methods. This contradicts every principle of naval construction we understand. The intelligence gathered through Operation Tetsukabe revealed systematic American innovations that Japanese industry had never considered. Welding techniques that replaced traditional riveting, allowing faster construction and superior structural integrity. Modular construction methods that enabled simultaneous work on multiple ship sections. Standardized components that could be manufactured independently and assembled rapidly. Most disturbing was the discovery of American damage control capabilities. Captured technical manuals revealed compartmentalization systems far more sophisticated than Japanese designs. American ships featured multiple redundant systems, extensive firefighting equipment, and damage control procedures that enabled vessels to survive hits that would doom Japanese ships. The psychological impact on Japanese naval leadership was profound. Admiral Chuchi Nagumo, reviewing Operation Tetsukabe findings, reportedly stated, "We are fighting an enemy whose industrial methods we do not comprehend. They produce ships faster than we can sink them, and their ships survive damage that would destroy ours." By early 1944, Japanese naval strategy began shifting from offensive operations to defensive preservation of remaining fleet assets. The realization that American shipbuilding capabilities exceeded Japanese sinking capacity fundamentally altered strategic calculations. The mathematics of naval warfare had changed, and Japan found itself on the wrong side of an equation it could not solve. The breakthrough that would explain American naval superiority came from an unexpected source. On January 18, 1944, the Japanese destroyer Akizuki recovered debris from USS Pennsylvania after a torpedo attack near the Caroline Islands. What Chief Naval Constructor Kenji Nakamura discovered in his Yokosuka laboratory would revolutionize Japanese understanding of American shipbuilding. The steel samples exhibited properties that defied conventional metallurgy. Japanese steel, forged using traditional methods perfected over decades, achieved excellent hardness, but remained brittle under extreme stress. American steel demonstrated characteristics that Japanese scientists initially dismissed as measurement errors. The samples showed extraordinary ductility, combined with tensile strength that exceeded Japanese specifications by 40%. "This material bends, rather than breaks," reported Nakamura to the Naval Technical Department. "Under stress loads that would shatter our hull plates, American steel deforms and recovers. It absorbs impact energy rather than transmitting it throughout the ship's structure." Further analysis revealed the revolutionary innovation. American shipyards were using electric arc welding extensively, creating molecular bonds between steel plates that Japanese riveting could not match. Traditional Japanese construction joined plates mechanically, creating stress concentration points where rivets connected sections. American welding created continuous steel structures that distributed stress loads across entire hull sections. The implications staggered Japanese engineers. Electric welding, dismissed by Japanese naval architects as unsuitable for critical applications, enabled Americans to build ships that functioned as single, integrated structures rather than collections of joined plates. This fundamental difference explained why American vessels survived damage that would break Japanese ships apart at rivet connections. Technical specifications captured from a damaged American welding manual revealed the scope of innovation. American shipyards employed automatic welding machines capable of producing continuous seams at rates impossible with manual techniques. Submerged arc welding created joints stronger than the base metal itself. Gas tungsten arc welding enabled precision work on critical structural components. Japanese attempts to replicate these techniques encountered immediate obstacles. American welding required electrical power infrastructure that Japanese shipyards lacked. The techniques demanded precision temperature control and specialized electrode materials unavailable to Japanese industry. Most critically, American welding methods required trained operators whose skills differed completely from traditional Japanese shipbuilding craftsmanship. Captain Tamichi Hara, observing welding trials at Kure Naval Arsenal, documented the cultural challenges. Our master shipwrights possess generations of traditional knowledge. American methods demand industrial workers trained in electrical processes. We are asking artists to become electricians. The strategic implications became clear through mathematical analysis. Japanese shipyards, optimized for traditional construction, could not adopt American techniques without complete infrastructure reconstruction. Converting existing facilities would require 18 to 24 months minimum. Assuming availability of materials and equipment that American submarines were systematically targeting, WWII March 1944, Japanese naval leadership faced an insurmountable reality. American shipbuilding techniques represented not merely improved methods, but fundamental industrial revolution. Japan possessed neither the electrical infrastructure, specialized materials, nor trained workforce necessary to compete with American construction capabilities. Admiral Shigetaro Shimada, Navy Minister, summarized the situation in his classified report. American naval construction employs industrial methods beyond our current capabilities. We cannot match their production rates or structural superiority without transforming our entire shipbuilding industry. The systematic deployment of American welding technology reached full scale by April 1944, transforming naval warfare across the Pacific. Japanese forces encountered American vessels that absorbed punishment beyond all previous experience. While their own ships remained vulnerable to damage that American construction techniques had essentially eliminated. During the Battle of the Philippine Sea in June 1944, the disparity became devastatingly apparent. Japanese pilots scored multiple direct hits on American carriers that continued launching aircraft. Dive bomber attacks that should have disabled flight deck operations caused superficial damage to welded steel structures designed to absorb and distribute impact forces. Lieutenant Saburo Sakai, Japan's leading naval aviator, documented the psychological impact in his mission reports. We achieve hits that would sink our carriers. Yet American ships continue fighting. Their damage control teams repair battle damage faster than we can inflict it. We are fighting ships that refuse to die. American damage control procedures, enabled by welded construction, had evolved into systematic rapid response capabilities. Compartmentalization systems featuring welded bulkheads contained flooding more effectively than riveted barriers that failed under pressure. Welded joints maintained watertight integrity even when surrounding structures suffered significant damage. The USS Yorktown's survival at the Battle of Midway, despite multiple torpedo and bomb hits, demonstrated principles that Japanese naval architects were only beginning to understand. Welded construction allowed the carrier to absorb damage that would have broken riveted vessels into separate pieces. Emergency repairs, impossible with traditional construction methods, restored combat capability within hours. Japanese intelligence obtained detailed damage assessment reports through captured American technical documents. These analyses revealed that welded ships could survive flooding in multiple compartments simultaneously, maintain structural integrity despite extensive battle damage, and continue operations with systems that would be completely disabled on riveted vessels. The production advantage compounded the technological superiority. American shipyards were launching welded destroyers every 2 weeks, while Japanese yards required 4 to 6 months for riveted construction. The mathematical progression spelled inevitable defeat. American production exceeded Japanese sinking capacity by factors that grew larger each month. Commander Yasuo Fujimori, Naval Intelligence Technical Section, calculated the strategic implications in his classified assessment. American welding enables both superior ship survivability and accelerated production. We face enemies whose ships are harder to sink, and who build replacements faster than we can destroy them. Desperate, Japanese attempts to counter-welded construction included development of larger torpedoes, designed to overcome superior American damage resistance. The Type 93 Long Lance torpedo, modified with enhanced warheads, proved marginally more effective but could not address the fundamental disparity in construction methods. By September 1944, Japanese naval strategy shifted entirely to preservation of remaining fleet assets. Engaging American forces meant facing vessels that survived attacks while inflicting damage on Japanese ships designed according to obsolete principles. The technological gap had become strategically insurmountable. Captured American welding equipment, studied at the Yokosuka Naval Technical Institute, confirmed Japanese fears. The machinery required electrical power infrastructure, specialized materials, and technical expertise that Japanese industry could not provide within timeframes relevant to the war's progression.
The psychological impact of American welding technology extended far beyond tactical engagements. By October 1944, Japanese naval personnel reported widespread demoralization as they faced enemies whose ships seemed invulnerable to conventional attack. The fundamental assumptions underlying Japanese naval doctrine had crumbled under the reality of American industrial innovation. Admiral Jisaburo Ozawa, commanding the remnants of the combined fleet, documented the cascading effects in his classified communications to Naval General Staff. Veteran pilots refused suicide missions against targets they knew would survive their attacks. Submarine commanders reported reluctance to engage American convoys, knowing that successful torpedo hits no longer guaranteed sinking enemy vessels. The Imperial Navy's response revealed the institutional inability to adapt to revolutionary change. Traditional Japanese naval culture emphasized individual skill, tactical excellence, and spiritual determination. American welding technology rendered these advantages irrelevant by changing the fundamental nature of naval combat from precision strikes to industrial attrition. Captain Rikihei Inoguchi, analyzing engagement data from the Leyte Gulf battles, calculated that Japanese forces required 3 to 4 times normal ordnance expenditure to achieve damage levels that previously resulted from single hits. "We are fighting mathematics," his report concluded. American construction methods have altered the basic equations of naval warfare. Intelligence intercepts revealed American confidence in their technological superiority. Captured radio communications showed American commanders accepting engagements that Japanese doctrine considered suicidal, knowing their welded ships could absorb damage that would destroy conventionally constructed vessels. This tactical aggressiveness accelerated Japanese losses while preserving American strength. The industrial implications proved equally devastating. Japanese attempts to retrofit existing ships with welding modifications encountered immediate obstacles. Welded repairs on riveted hulls created structural weak points where different construction methods met. Emergency welding using improvised equipment often failed under combat stress, creating additional vulnerabilities rather than improvements. Training programs to teach Japanese shipyard workers American welding techniques collapsed within months. traditional craftsmen, accustomed to precise riveting work, struggled with welding processes that required completely different skills. The cultural transformation necessary to implement new construction methods exceeded available time and resources. By December 1944, Japanese naval strategy acknowledged defeat in the construction competition. Admiral Soemu Toyoda's final operational directive emphasized preservation of remaining assets rather than engaging American forces equipped with technologically superior vessels. The combined fleet, once the terror of the Pacific, had been reduced to avoiding combat with enemies they could no longer effectively damage. Prisoner interrogations conducted by American intelligence confirmed the psychological collapse. Japanese naval personnel consistently cited welded ship construction as evidence of insurmountable American technological superiority. Many expressed belief that Japan lacked the industrial capacity to compete with nations capable of such revolutionary innovations. The broader implications transcended naval warfare. Japanese leadership recognized that American welding represented systematic industrial advancement that extended across all military production. If Americans could revolutionize shipbuilding so completely, similar innovations likely transformed aircraft manufacturing, weapons production, and logistics systems. The discovery of American welding marked the moment when Japanese resistance shifted from tactical fighting to inevitable delay of predetermined defeat.
The final transmission from Admiral Matomi Ugaki on August 15, 1945, acknowledged what Japanese naval leadership had recognized months earlier. American welding technology has rendered our fleet obsolete. We face enemies whose ships cannot be sunk by weapons designed for conventional construction. This admission marked the end of an era in naval warfare and the beginning of industrial shipbuilding dominance. Post-war investigations by the United States Strategic Bombing Survey documented the complete scope of American technological advantage. Japanese shipyards, optimized for traditional riveting, had proven incapable of adapting to welding methods within militarily relevant timeframes. The industrial transformation required exceeded Japan's wartime capabilities by several orders of magnitude. The psychological impact persisted long after military defeat. Japanese naval officers interviewed during occupation proceedings consistently identified welded ship construction as the moment they realized defeat was inevitable. Captain Atsushi Oi, former operations officer of the combined fleet, testified, "When we understood that American ships could survive attacks that would destroy ours, we knew we were fighting industrial capacity rather than naval skill." American shipbuilding statistics revealed the crushing mathematics of welded construction. By war's end, American yards had launched over 2,700 Liberty ships using standardized welding techniques. These vessels, constructed in an average of 42 days each, exceeded the tonnage of the entire Japanese merchant marine lost during the conflict. Industrial production had overwhelmed traditional craftsmanship completely. The technological legacy transformed global shipbuilding permanently. Welding techniques developed for American wartime production became standard practice worldwide. Traditional riveting, which had dominated ship construction for centuries, virtually disappeared from major shipyards within a decade of war's end. The innovation forced by combat necessity revolutionized an entire industry. Japanese shipbuilding, reconstructed during the post-war period, adopted American welding methods extensively. Former naval architects who had studied captured American equipment became leaders in implementing the same techniques they had once been unable to counter. The students became practitioners of the methods that had defeated them. Modern naval historians recognize the welding revolution as decisive in Pacific naval warfare. The technology shortened the conflict by enabling American forces to absorb damage while maintaining offensive capability. Without welded construction, American casualties would have been significantly higher and the war's duration substantially extended. The human cost of technological disparity remains documented in naval archives. Japanese naval personnel faced enemies whose ships survived attacks that should have been lethal, while their own vessels remained vulnerable to damage that welded construction could prevent. This asymmetry in survivability translated directly into asymmetric casualties. Today, every major naval vessel worldwide employs welding techniques that trace directly to American wartime innovations. The emergency industrial methods developed to overcome Japanese resistance became the foundation of modern shipbuilding. Combat necessity had accelerated technological development by decades, permanently altering maritime engineering. The lesson transcends naval warfare. Industrial innovation, properly applied, can render traditional methods obsolete overnight. Japanese naval excellence, developed over generations, proved worthless against American production techniques that changed the fundamental nature of naval combat. Superior tools, backed by industrial capacity, had triumphed over superior training and traditional skill.